So let us continue with question number 5, which is part of. Okay, we have a lot of things actually on question number 5. That is the definite integrals, the part of areas and volumes, and also the second moment of area and the moment of what inertia. Yeah, this is the part that covers question number 5. So those are the ones that you must expect, and this is what we have. So quickly going through the questions that we are given. The first part we are given 5.1. Determine by integration, all right, that is the integral of this, e to the exponent of minus st times f of t with respect to t, if our f of t is given by this term, f of t is represented by this, all right? So in place of f of t, simply substitute what you are given, all right? And sometimes you can even avoid working with negative exponents like what we have on this part, all right? 7 over 3, 7 over 3t to the exponent of minus 1. It is the same as 7 over 3 t like this, all right? T to the exponent of negative 1, it's 1 over t. So it will be 1 over t like this, which is going to give us what? T, the reciprocal of 1 over t. So that's 7 over 3 times what? Times t. So this is the same as 7 over 3t, something that we can properly see. So this is what you're going to simply do. You're going to substitute as it is, all right, e to the exponent of minus st. Then our f of t, which is what? 7 over 3t. With respect to what? With respect to t. We can integrate this. All right. 7 over 3 is a constant, so you can even take it out of the integral. So you're going to have e to the exponent of minus st times what? Times t. That's with respect to t. And remember, there's a product of two terms, an exponential to an algebraic. So we can actually use our by parts integration, choosing our f of t from Eilert concept, exponential versus what? Algebraic. So you're going to work with what? Algebraic as our f of x. Remember your by parts formula, guys, given in terms of f of x, but here it is in terms of what? T. So we are going to have its integral as, remember, it was supposed to be f of x, but it's going to be f of t instead, times gt minus the integral of f prime t times what? Times gt with respect to t. So we are going to integrate from our by parts using that concept, all right, where our f of t is the one that we are choosing from our Eilert, and that is algebraic in this order. So our f of t, we are going to consider the algebraic, which is t. So if our f of t is equal to t, differentiate to obtain the first derivative, that's a 1, all right, then the remaining part is going to be g prime, this e and dt. That's g prime t dt like this, which is e to the exponent of what? Minus st. So you're going to integrate this so that we obtain our gt, and the integral of an exponential is going to be the derivative of this is what? Of minus st is negative s. You divide by the derivative. All right, so that's simply a negative. All right, you can even just write as negative e to the exponent of minus st over what? Over 3. The negative, you can take it up over s. You can take this negative up. So this is what you're going to have, and simply substituting into the formula, f of t, we have it, that's t All right. Then we're going to multiply to this, our gt minus e to the exponent of minus st over s. All right. That's negative the integral of f prime t. All right. That's 1. All right. That's simply 1. So there's no need of. All right. E to the x minus e to the exponent of minus st over what? Over s. So you're going to integrate with respect to t. And that's the idea there. And you have our limits. After that, here we're going to have our limits from 0 to infinity. All right. So this was going to give us 7 over 3. All right. Let us try to simplify, then integrate this one. All right. Here, this is over 1. So simply consider the product, the numerator to the numerator. So that was going to be simply negative e to the negative t times e to the exponent of minus st over what? Over s. Okay. Minus and minus is going to give us what? A positive here. Then we integrate this. So if you integrate that e, it is going to give us this. Remember, this was the integral, and this is what we got. So it means from the positive that we have, we multiply with the negative. So it was going to be negative. All right. So it's going to be like this, negative e to the exponent of minus st over s. But there is this s that we have in the denominator. So it's going to be s times s, which is what? S squared. So this is going to give us what? S squared. All right. So take note of the sign here. The minus and the minus cancelled gave us a positive. But when you integrate this, you're going to have what? A negative. So that is the idea of what we are having. So we have integrated this. Then let us have our limits from 0 to infinity. So just like that, guys, we have to put the limits, all right? Just avoid these negative exponents. Just rewrite, take the negative down. So it's be negative t over what? S times e to the exponent of st. All right, take this one down. So it's going to be negative 1 over s squared e to the exponent of st. All right, it's best that we work with this condition, avoid those negative exponents. All right, so this is what you're going to have by substituting our limits. All right, the infinity. When you substitute the infinity on the first part here, what are you going to have? It is going to give us infinite over what? Over infinite. This is infinite there, and this is e to the exponent of infinite is what? Infinite. And once this happens, guys, remember your derivative part where you have to differentiate the numerator and what? The denominator from our L'Hospital's rule. So meaning to say, you are going to differentiate, all right? That's negative 1. If you differentiate this, negative 1 over what? The derivative of an exponent, you just drop the power, the coefficient of what? Of t, which is s. So s times s is going to give us what? S squared e to the exponent of what? St. Remember, we are talking about the limit being what? Infinite. So if you substitute that infinite again, it was going to be negative 1 over, this is going to give us infinite, e to the exponent of an infinite. That's what? Infinite. And we know that a constant over infinite, guys, is what? It's a 0. There's nothing like minus 0, so it's just what? A 0. So that's what you're going to have. If we substitute an infinite on the first part, the answer is going to give us what? A 0. From this idea, from our L'Hospital, so to differentiate, substitute the limit again, which is our infinite, and it gives us what? A 0. All right, minus infinite here, that's going to be 1 over infinite, and 1 over infinite is what? It's a 0, so that's 0 minus 0. Okay, then we move on. We have substituted what? We have substituted the upper limit, which is this one, all right, which is our infinite there. All right, so that was the condition of our part. Then we move on to the lower limit 0. We substitute again in place of t. If we're going to put a 0, this one was going to give us a 0. All right, it was going to be 0 over e to the exponent of 0. It's 1, so that's 1 times s, which is what? Which is s. So 0 over s. All right, it gives us a 0. All right, it's just like 0 over 3. That's what? That's a 0. So here we are going to obtain a 0 minus, if we substitute a 0 here, it was going to be 1 over s squared times e to the exponent of a 0 is what? It's 1. So that's 1 over what? 1 over s squared. So this is it. Just like that. So you're going to obtain 7 over 3. 0 minus 0, that's a 0. This is going to give us a minus, and a minus, that's a positive, 1 over s squared. So simply, that's 7 over 3 times 1 over s squared. Just like that. Times 1 over s squared. So that's 7 times 1, which is 7. 3 times s squared, that's s squared. So this is what you're going to have. You have applied the Laplace transform, all right? This is part of the Laplace transforms. Go through that, understand all the basics from what you are given, all right? Just a matter of revision. It's all about revision. Let us consider another one. 5.2, you're given two graphs, all right, to consider. All right, x is equal to this, which we can write, as y is equal to, take x to the other side, it's going to be 1 minus x. All right, it's going to be a negative. So, and y is equal to the square root of this. 5.21, calculate the coordinates of the points of what? Intersection. All right, remember, for the points of intersection, the two graphs has to be what? Equal. The graph of y is equal to 1 minus x, and of y is equal to the square root of 1 minus x squared must be equal at the point of intersection. So that's simply equate these two. 1 minus x is supposed to be equal to the square root of 1 minus x squared. All right, let's get rid of the square root. Square both sides. You have to square both sides to get rid of what? The square root. You have to square. 1 minus x squared is going to be 1, all right? Minus 2x plus what? X squared. Expand the brackets. You're going to have two brackets. It's up to you, or you can use a minus b squared, which is a squared minus what? 2ab plus b squared. So this is what you're going to have. All right. The right-hand side is simply getting rid of what? The square root. So you remain with 1 minus x squared. So this is what you have after squaring. And we can take the terms on the right-hand side to the left-hand side. That is going to give us what? X squared plus x squared. This is going to be positive. So that's 2x squared. All right. Minus what? Minus 2x. 1 to the other side is going to be a negative. 1 minus 1, that's a 0. So this is what you're going to have. Solve for x. From this equation, solve for x. All right. We have an equation, guys. Simply solve for what? For x here. How can we solve for x? Simply factorize. 2x is the highest common factor. Divide 2x and 2x. That's x, 2x, and 2x minus 1. So this is 2x squared. And 2x is going to be x. And that's equal to 0. Each part from the product here is supposed to give us a 0. 2x must be equal to 0, or x minus 1 must be equal to 0. So that's it. We're going to have the value of x, which is 0, or x is equal to what? Positive 1 to the other side here. So that is the condition, just like that. Just like that. So I want us to use these values to find the y values. For the value of x, which is equal to 0, we can substitute in any of these two equations. So when x is equal to 0, y is equal to what? Put a 0 there. 1 minus 0, that's 1. So that's a point 0, 1, a point xy. We move on to another value. When x is 1, substitute 1 here. y is equal to 0. So that's a point, 1, 0. So these are the 2 points that you're going to have as our points of intersection. All right. That's the idea there. Points of what? Intersection. All right. No problem. No problem. Let me just do it this way. So we have our points of intersection on 5.1. Moving on to another part of the question, 5.2. Make a neat sketch to show the enclosed area, the representative strip, and the points of intersection. All right. So if we are to consider for our sketch, we are given a linear function y is equal to 1 minus x. This is a linear, a straight line. And we have got y is equal to the square root of 1 minus x squared. This is a semicircle. We are not given plus or minus. If we are given plus or minus, it is going to be a full circle. So here, we are going to take the sign as a positive, meaning to say we have got what? A half circle, which is taken above the x-axis. Above y is what? Positive. Where it is given in the form y is equal to the square root plus the square root of r squared minus x squared, where r is the radius. So 1 there from r squared, if it is 1, so it means our r is what? The square root of 1. All right, so that's the square root of what? Of 1, which is simply plus or minus 1. So our radius is 1 unit. That's a circle, that a half circle that we have above what? The x-axis. For a linear function, what do you need to sketch? We simply need the x-intercept, where y is equal to what? Where y is equal to 0. What is the value of x? 0 is equal to 1 minus x. So take x minus x to the other side. That's x, which is what? Which is 1. We have our x-intercept. And the y-intercept, where x is equal to 0. So if x is equal to 0, y is equal to what? 1 minus 0, y is equal to 1. So guys, this was this was a straight forward question, guys. We've got our x and y like this, and that's all values are around 1. All right, so that's 1, minus 1, 1, and minus 1. So the x-intercept, it's a what? Positive 1 here. The y-intercept is positive 1. So that's a straight line. We can have our straight line. All right, this is just a sketch, guys. Y is equal to what? 1 minus x. Okay. Then we've got a semicircle here, which is taken radius to be what? 1, and it's above the x-axis. So we're going to have our semicircle here, 1, 1, 1, like this. So this is it. This is what you're going to have. This is what you're going to have. That's your sketch. So the points of intersection, that's here, 0, 1, 1 is 0. Exactly the points of intersection that we have, 0, 1, and what? 1, 0. So the enclosed area, the one that is covered by the two graphs, is this part. This is the part that is enclosed here, covered by the two graphs. So we can use the values of x at 0 and 1. So therefore, our representative strip is going to be for what? For x. Since we have got the limits for x, our strip is going to represent what? X values, where x is what? 0 and what? 1. Those are the limits that we are going to what? To use for calculations of area and volume. And we can have an understanding that y is equal to square root of 1 minus x squared is above the line, the straight line. So this is the one on top, and this is one below. So you can just call this one y1, and this one we're going to call it y2. All right, top minus bottom in terms of your calculations. All right, so that is the idea. This one is on top, This one is in the what? In the bottom. Guys, this one just for understanding. All right. So that was the sketch. That was the sketch. And after that, they want you to determine now the magnitude of what? The area. Calculate the magnitude of area in question what? 5.22. So we can determine the area. Remember, when given two graphs like this, we can determine the area as the one that is in between. So subtract the top minus the bottom. So this is area with respect to x. The strip is for x. So that's y1, the top minus y2. With respect to x, we can integrate from a to b, which are the limits. So just like that, guys, just like that. So let us have this from 0 to what? 0 to 1. These are the limits. Y1, this is the semicircle, square root of what? 1 minus x squared minus y2, that's 1 minus x. All right, so we are going to integrate this with respect to x. All right, let us just try to simplify first before integrating. That's the square root of 1 minus x squared minus times 1, that's minus 1, minus times minus x, expanding these brackets is going to be what? A positive x. So this is what we're going to integrate with respect to what? With respect to, just like that. So integrating here, I want us to see something on the first part. All right, this integration of the square root of 1 minus x squared, the square root, there is going to see that is very, very complicated that you're going to integrate that one direct. But guys, look into your formula sheet. You'll see that they are integrals that we are given from those trigonometric substitutions that can be very, very useful here. This is supposed to be page 4 of your formula sheet. All right. If you check these integrals, they can be very, very useful on this page. So how do we apply these? We look into this format. We must have any one of these what? Formats. So in our case, we have got the square root of what? 1 minus x squared. All right. So I'm going to write that format. Sorry for that. The square root of what? The square root of 1 minus x squared. Do we have a format similar to this exactly? The square root of a squared minus x squared. A, it's a constant. It's the same as this. The square root of 1. 1 is same as what? 1 is squared minus x squared is just 1 and the same. So our a is what? Is this 1. So a is 1. So wherever we see a on this integral, this is the integral that corresponds. Wherever we see a, we're going to put what? We are going to put a 1. So this is a squared. So that's 1 squared. This is a, we're going to put a 1. This is a, this is 1. So it means we're going to obtain 1 squared. That's 1 over 2. Arc sine of what? X over 1, which is x. So that's arc sine of x plus x over 2. The square root of 1 squared, which is 1 minus x squared plus c. So this is it. From this formula, a is 1. So simply put a, which is 1. So this is the answer that you're going to have here on this integral. All right. So I'm just going to rewrite this one as it is. All right. So let us rewrite this one as it is. So we saw that it's going to give us 1 over 2 arc sine of what? Of x plus x over 2. The square root of 1 minus x squared. So that's it. We have integrated this part. Then we move on to the next term, minus 1. Integrate with respect to x. We're just going to multiply by what? Multiply by x. X, you add 1. So that will be what? X squared over 2. So this is it, guys. We have integrated. Then we can substitute our limits. Upper limit minus what? The lower limit. And your calculator must be in radians. When substituting this arc sine, whatever that you have there, your calculator must be in what? In radians. So arc sine of 1 plus 1 over 2 the square root of 1 minus 1, which is a 0 here, 1 here, plus 1 squared over what? Over 2. Your calculator in radians. Then 0 there, 1 over 2. That one is going to just give us a 0, this one. Plus this one is a 0, guys. Any number times 0. This is 0. This is 0. This one is just going to give us a 0 there. So simplify this part, all right, on your calculator. Like I said, must change your calculator to radians. So you're going to obtain 0.285 minus this whole part was going to give you a 0. So that's our area with respect to x in what? In square units. In square units or units squared. Just like that. You have the what? The area. The area. So you see these integrals, guys, revise every part of your integration. Formula sheet, you must know your formula sheet in and out. All right? You must know your formula sheet in and out. And every other aspect that you have according to your syllabus. All right, so that was 5.23. Then the volume, this time, they want us to have the volume 5.24 of the solid rotated. When it is what? Rotated about the x-axis. So that's our Vx. So the strip is for what? The strip that we are going to use, or the element is for what? For x. So that's our Vx. All right, the volume for x, that's the integral of what? Y1 at the top. So in our case, it's Y1. All right, the formula sheet, I think they wrote like Y2 minus Y1. So you put 2 and you put 1. All right, or you can just use 1 and 2. As long as you understand this is the top minus what? Minus the bottom. So the numbering does not matter. All right, minus Y2 squared according to what we have here. So this is the formula for x. So let us integrate this part y1, the top, the square root of what? 1 minus x squared. But it must be squared. You must square it. All right. Minus y2 squared, the bottom one, 1 minus x. But we must what? We must square it. So this is it. Let us integrate with respect to x. All right. If we square this, it's an advantage, guys. Very, 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 very advantageous to us, because the square root and the square neutralizes. So it's simply, you're just going to take what is inside of what? The square root. This neutralizes. So meaning to say, it is going to be 1 minus x squared. Minus the expansion of this bracket. Remember, guys, we expanded this before we got this. All right. So this is what you're going to have. We need to expand the brackets, collect like terms, then integrate. We are done. So, guys, mathematics is one of the easiest, you see. One of the easiest, just following. So let's expand this bracket, then collect like terms. All right, minus and this, that's negative 1, positive 2x, negative positive, that's a negative x squared with respect to x. So we can expand the brackets first, then what? Then collect the like terms. That's going to be minus x squared minus x squared is what? Negative 1. So that's negative 2x squared plus what? Plus 2x. 1 minus 1, this one cancels. So that's going to give us what? That's going to give us a 0. This one cancels. So this is what you're left with. You just need to integrate, then substitute what? The given limits. You have your what? Your volume from there. All right, so let us integrate. Simply add 1 here. That's to the exponent of what? If we add 1 to the exponent of 3, minus 2x to the exponent of 3 over 3, plus this, we're going to add 1. So that's 1 plus 1, which is 2. 2x squared over 2. So this cancels, and you remain with x squared. With our limits from 0 to what? 0 to 1. That is going to give us the volume of what we are given. Upper limit is 1. That's it. 1 squared. So this is our upper limit minus the lower limit. That's a 0. That's a 0 there. So this is simply going to give us what? A 0. So let's see, guys, simplify this. All right. We're going to obtain the numerical value there was going to be minus 2/3 plus 1, which is a third. And this is a 0, guys. So it's just going to be a third. So that's pi over 3 cubic units, or as a decimal, 1.0, 1.047, 1,047 cubic what? Cubic units. So you have got what? The volume. You have got the volume, just like that. This is a volume. So you see, it's a repetition. We have dealt with these questions, guys, now and again, now and again. So do more revision. All right, that was 5.2. Let us move on to 5.3. The moment of inertia. All right, calculate the moment of inertia of a circular lamina of what? Radius r and mass. All right, so this is it. This question, guys, just take it. It's as it is. It's gonna be a repetition. They just repeat these moments of area and what moments, the moment of inertia. In order for you to have the moment of inertia, these are the steps that you're gonna use. All right, it's a circular lamina, so just have your sketch. All right, just have your what? Your sketch. And on this sketch, what you're going to do is to represent the strip, all right? Since it is a what? Since it is a circle. It is a circle of radius r. So from here, the origin to the circumference of the circle, it is our radius. But we are going to have the strip. This strip has got its own radius. This strip, or the element, all right? This one. It is going to be taken at a certain radius. So we can just call its radius x. So x, that's radius of what? Of strip. And, right, strip. And that is, we have got the radius of the strip and the width of the strip, which is the, when you consider the representative strip in terms of the calculation, is going to be delta x. All right. So x is the radius, which is actually the distance. It is the distance that represents what? The strip. It is that is the distance that you consider for the what? For the strip. All right. The distance of what? Of the strip, x. This one, let me just write is distance of what? Distance of the strip. That's our x. So you must know the distance from the reference axis, all right? Then from here, you must calculate the mass of the representative strip. It is taken at a certain mass. So the mass of strip, all right, the mass of strip is equal to the area of strip times the mass per unit area. Mass per unit area. Mass per unit area. I think I was supposed to have finished this topic. I left it somewhere. I'm going to work on it. But this is what you're going to need. So the area of strip is here. This is our strip, remember? So its area, if we are to take this circle and expand it, it's going to be like this. This is the area. So we have got the length is going to give us the length, which is 2 pi x, 2 pi r. Our r is x. All right. Remember, x is the distance, but it represents what? The radius. So it was supposed to be 2 pi r, but it's 2 pi x. We chose to use what? X there. We cannot use r because it's representing what? This one for the circle. And this is the width. All right. Remember we said delta x is the width, so this is the width, so it's length times width. That's you're gonna have what? Area of what? Of strip. Area of what? Strip. Length times what? Width. So it's gonna be here. Area of strip 2 pi x times what? Times delta x. Length times width. So we have got what? The strip area times the mass per unit area. This is not strip area, this one. The area that we're talking about is of the shape that you're given, original shape, the circle, this one, not area of strip. The strip is one that is inside there, inside of a circle. But the area here is the area of the whole circle. So the area is pi r squared of the whole circle. So mass per unit, it means mass over area. Mass m over what? Over area. So it's mass over area. Area is what? Pi r squared. So this is it. This part. This is it. This is the mass of what? Of strip. And that is going to be used now in our calculation of what? Of our inertia, because our inertia is simply going to be given by distance from the reference axis. So distance from what? The reference axis squared times what? Mass of strip. Times mass of strip. So we can find our integration now for the moment of what? Inertia. Because the distance from the reference is what? Is x. The distance of what? The strip. Remember, it is what? X. That's the difference from the reference. So it's x. So it was going to be x squared. Distance here, x what? X squared. Times the mass of the strip. Remember, this is the mass of the strip, this one. 2 pi x times delta x times what? M over what? Pi r squared. So this is what you're going to have, that you're going to actually integrate with respect to x. Delta x integrated with respect to x, you've got what? Your moment of inertia. And the limits are the radius of the circle. The limits now is the radius of the circle from that radius of the circle. So that's from 0 to r, radius of the circle. These are your limits now. So that is it. So let us integrate, guys, and see. Since we are to integrate with respect to x, it means we can take these 2 pi outside, but also simplify here. Pi and pi was going to cancel. So meaning to say, we are left with the constants 2 and m and r squared. So 2m over r squared is a constant. It can be, we can take it outside of the integral, 2m over r squared. Since we are to integrate with respect to what? With respect to x, you must be left with x. That is the variable to be considered. So x squared times this x is going to give us what? X cubed. So this is what you're going to integrate with respect to what? With respect to x. Then you have your limits. You are done, just like that. You are done just like that. So these are the steps that you're going to need. I'm just going to give you a follow-up notes, all right, on another episode. I'm going to continue with the classes that I was doing. On those moments I did not finish, so I'm going to write the notes properly. But this is for revision. I think you can just follow up. This is what you simply need for the moment of inertia. You have a sketch, find the distance of the strip. You must know it. Then calculate the mass of the strip. Then use this formula. You are done. You are done. Just like that. Use the formula that you're given. So it can be used for any question. Is it a rectangular part or what? So let us integrate 2m over r squared. Integrating x to the exponent of 3, we're going to add 1. So that's x to the exponent of 4 over 4. Our limits taken from 0 to r. We have integrated. So substitute the limits. Upper limit minus what? Upper limit minus the lower limit. So that's 2m over r squared our upper limit, r there is going to be to the power of 4 over 4 minus the lower limit is going to give us a 0. All right, so that's it. So meaning to say you were going to have 2m over r squared times this. This is what you're going to have, r to the power of 4 over 4. And we can just reduce 2 into 2, that's 1. Here, that's a 2. R squared, 1. Here, it's going to be r squared. So that is equal to m times r squared, m r squared over 1 times 2, that's a 2. So this is it. This is the idea, which is taken in kilogram square units. All right, we are not given the units here. We are not given the units, guys, to say of this radius. If it was given in centimeters, kilograms per what? Per kilograms square centimeter. If it is in meters, kilogram square meters, but we are not given because it is taken in terms of what? It is taken in terms of mass. So it's kilogram per square unit. Kilogram per square unit. The square unit here is from what? A radius squared. So that's the square unit of what? The radius. But the mass is in what? In kilograms. So this is what you're going to just write your units as. It is still okay like that. All right, so these are the typical questions. As you can see, they are going to ask questions based on this part. All right, so yeah, I'm gonna try by all means, guys, as we are wrestling with time, to add more clarity on this part as a separate, working it as a separate, like as a topic. I've introduced one or two, but I did not finish it. So just stay tuned, all right? Stay tuned for more. This is what we are going to do. We just have to add more on this part.